Good morning, everyone, and a very warm welcome to this second round of webinars on Secure Swiss Finance Network. Some of you may have been around in the first round of webinars, which we held last September. This year we're holding again webinars. We had one last week in German, and today we are doing it in English. Starting off, I'd like to give you a warm welcome here and introduce the speakers, which we will give you today an input. Beat Stump, our senior network engineer, will give you deep insights into technicalities of Ssfn, into what it takes to get an access to Ssfn and how to run it. Thomas Reske, our senior product manager and product manager for Ssfn, will give you an insight into what Ssfn is as a total system, while I will be here to do the introduction and then do the wrap up and the question sessions right at the end. Maybe some do's and don'ts. Please do ask questions anytime. Please write the questions in your chat function here. We will turn off the camera for all non-presenters at all times. In the question session there, we will open up microphones so that you can actually also ask a question there orally. And if you have at any point you would like to mention something, I think you can also raise your hand. As I said, please feel free to ask questions beforehand or afterwards. I would also like to mention that we are recording this session and that we will make the presentation itself available most probably as of next week. So do take notes, but do also be aware that you will receive or you will have access to the presentation next week. You might also have the video itself also online. So having said that, what is the program for today? Mentioned, Thomas will give you an overview, what is Ssfn, and then the main focus will be given by Beat, who will give you a deep insight into the implementation of Ssfn itself and into design layouts and such more of Ssfn. I will then close up with the wrap up and moderate the question session. With that, Beat, I'd like to, excuse me, Thomas, of course. Thomas, I would like to hand over to you and thank you for your presentation.
Good morning, everybody. Yeah, before I start to give you an overview about the Ssfn, not from a technical perspective, but from a governance perspective, etc., I'd like to take over. Now it took over control. Yeah. I'd like to give you a very short introduction to what is the SIX group doing. The SIX group does have 4 areas of activities. We do run the Swiss and the Spanish exchange, which is not included in our Ssfn activities at the moment. But what is included, these are the security services, which is all behind selling and buying stocks, everything which is required to handle over the securities and to obtain the money. Then we do have a financial information area, which deals with financial information like indices, like actual prices of stocks and etc. Where I'm from, this is the banking service department. The banking service department is responsible for the infrastructure, for the technical processing infrastructure for the Swiss banks, which are these infrastructure activities are focused on cash, everything around ATMs in Switzerland. about connectivity between companies and banks. It's about debit and mobile solutions, debit cards, and so on, and billing and payments, which means we do run the SIG system for the SMB. SIG system is the interbank clearing hub for the Swiss markets, and we support the market with billing activities, for example, e-bill. You can reach these services at the moment with our connection, our network, which is called Finance IPNet. And some bigger banks, they do have a so-called dark fiber, direct link connection to the SIX group. And these two connections are very secure, but they are really not flexible. It's a point-to-point connection. Whenever the system or the connection is down, it took some time to reconnect, and it's quite expensive. What you can also use for obtaining services from SIX is the internet, for example, the financial information. The internet is very flexible. It's quite redundant, but it's not safe. So these were the starting point to examine the infrastructure, what's in the market, what kind of possibilities do we have to start with a new generation of connectivity to our systems, and therefore we did start under the lead of Christopher. We did start a project which is called Ssfn, Secure Swiss Finance Network, and within these projects, there were the SMB, the Swiss National Bank, Anapaya as the commercial offerer of sign technology, and the partners in connectivity, Swisscom, Sunrise, and Switch. And we started the project with 3 pilot banks. And so this was quite a good group of stakeholders for the whole value chain for offering a network. And so we started with setting up a pilot network with some performance testing, with some testing regarding the security. Then we did define governance principles, which I can later on to it, and we identified use cases based on the offering of the 6 services, what we can offer our customers via Ssfn. Not only SIG and EuroSIG, but also other services we do offer. So I think it was 12 years ago that Zurich ETH started exploring the possibilities of network solutions based on the sign technology, and we started together with SMB and with the ETH. In 2017, our project activities, which lead to a project kickoff in 2020, and we did all the technical activities which are required to set up the network in the coming 2 years. And so we went live with Ssfn based on the sign technology in November 2021. And one big milestone we to reach in June 2022 with the going live of SIG and EuroSIG via Ssfn. The main difference, and Beat will give you much more details than I will be able to give you, is between Finance IPnet, which you find on the left-hand side, and Ssfn, which is on the right-hand side, is that Finance IPnet is a so-called hub and spoke architecture model, and the 6 here is in the hub, and all the banks, they do have a point-to-point connection to 6 for obtaining the services. It's quite limited, but it's secure, it's quite costly, and it's not very flexible. And Ssfn, it's a so-called any-to-any architecture, which means that the 6 is no longer the hub of this network. It's part of the whole infrastructure. And in the middle you see a cloud, but for me there must be a cloud around all the members of the network, because now we do have parties which do offer connectivity services. We do have participants of the network, and we do have 6, for example, which is offering services via this network. And within this network, we have a any-to-any connection, which means that all the participants can communicate to all the other participants, which is a big difference between the existing Finance IP network. And there are so many other details and features which will Beat tell you about. Which is also new is we do have now a governance model. In Finance IPnet, there is no governance model. There is no possibility for the members, for the participants to use a change request procedure or anything like this. And now we do have 3 different types of stakeholders. We do have the voting members, which are 6, SMB, and Switch are. The voting members are responsible for the governance model. They are responsible for the rules and regulations. They are responsible whenever there is a party which is not behaving right to punish this party. And we do have a group of service providers like Anapaya, for example, like Swisscom, like Switch, like Sunrise, and we are now in the process of welcoming other service providers, which will help to make the whole system much more stable as it is now. Of course, it is now very stable, but the more parties will do offer services within the network, the more stable, the more reliant it will be. And of course, we do have the Ssfn users. It's quite a closed shop. You must have a business connection to 6 for being a Ssfn user. At the moment, we expect around 350 banks and other parties which will be part of the Ssfn network in future. As I mentioned on the beginning, in June, there was really a big milestone. We issued a circular on May the 20th, which the content that SNB recommends now Ssfn for the SIG system. The SIG system is it's one of the most critical services in the Swiss financial markets. It's really the only interbank payment platform we do have. So whenever SNB recommends a connectivity like Ssfn for using the live SIG system, yeah, it's really says about the quality of the network. In this circular, there was mentioned that there will be in the near future a so-called endpoint security for all SIG participants which are using the system. That means that they do have to implement Ssfn on a end-to-end basis. So all SIG participants will have to use Ssfn within the next few months, very few years. So yeah, it's a really opportunity for offering these services. And I'm very proud to say that Ssfn is using now Ssfn for their own connection to the SIG system. And yesterday I did check whether everything is working smoothly. It is. And at least for the last 15 days, they used Ssfn only, not Finance IPNet or anything else. So yeah, they really rely on the quality of Ssfn. On the beginning, I told you what are the service fields of SIGs are, and I will end with what will be offered via Ssfn, which is reachable at the moment is all our ATM monitoring services, EuroSig SIG, which will comes quite soon. Is our e-bill services, FTP services, and which will come within this year is all financial information services, everything which is about debit online, Webmax, which is which you require for SECOM services, and the repo business will be available via our core application also within this year. So now, Beat, it's your part regarding all the technical details of Ssfn. Thank you.
Thank you, Thomas. And good morning from my side as well. I'm trying to give you some more technical details on what the whole technology of Ssfn is about, as well as what differentiates Ssfn from maybe any other Ssfn implementation or network that there is around. And I'm going to start with the question, why should we even do this? Thomas already gave you some of the motivation points that lead to checking this technology. Specifically on the left side, we see the two options that are in place today. So we have internet, it's open, it's fast, it's usually pretty much okay. However, there are always threats around, there are vulnerabilities, there are risks which we usually ignore. As someone once said about the internet, that we became comfortably numb about it. So we just assume it works, and usually it does, so we don't have to worry about it. But that's obviously not a good option for the financial market. So we have the second option, which is privatized and private technologies like layer 2 connections, like dark fibers, like layer 3 VPN services as we offer it with Finance IP. They are usually coming at the high cost, and at the same time they are quite inflexible, meaning that you have to usually have a communication between two parties and two parties only. So it's not possible to share this media for other connectivity options. And that's more and more becoming difficult and resource intense. So what does Ssfn or Sion as a technology offer on the other hand? What is really new, and I have to say from a technical point of view, I pretty much ignored it in the beginning, whereas I became to learn that this is one of the key aspects within Sion is the governance area. So of course, there's a segmentation. The segmentation is called isolation domain ISD. That's the technical part of it. We have the possibility to enforce rules and stuff, but for the first time, we really have a network where there is not the ownership on one party, but it's rather a distributed governance where basically all members are at the same time stakeholders of the networks and have the possibility to influence the structure of it and offer services on their behavior and so on and so forth. So kind of the attributes of the internet shared with more control. The ISD itself, as a technical instance, works independently from any other ISDs. So Ssfn is one ISD. There might be more ISDs, for example, the Swiss ISD, which is the, let's say, open one to the open community. That's a completely different entity with different control mechanisms and rules inside it. Those ISDs in a, let's say, full-blown Sion network in future, those ISDs are ideally all interconnected. For the moment, Ssfn is strictly encapsulated and segregated from everything else to avoid some complexity in this very early stage. Then we have the attribute of control. Sion technology offers an end-to-end path control for outbound traffic, so I can fully define the whole path throughout the network at the source where I'm sending my data. So at all times, I have control on where my data is passing. One example is I can implement geofencing rules in future. I could exclude certain paths of untrusted ISDs or less trusted ISDs. And of course, I can use path policies that are dependent on enhanced attributes. Like I could evaluate the paths against latency and say, I want for my traffic, the path to the destination which has the least latency on the way. Or I could use quality parameters where I can say, well, I want to use the path with the least packet loss in the past. And all those values are collected and can be evaluated going forward. The technology is pretty flexible about those enhanced attributes. So there are even ideas to introduce stuff like I want to use the greenest path because I could measure or I could add the attribute of how the power, for example, is created that is used to operate those data centers and stuff like that. There are fancy stuff and the opportunities are unlimited for now with adding attributes. It's just a matter of how we want to evaluate them in the end, and this defines on how we select the path. In addition, there's the multipath functionality. We know multipath from traditional routing, which is always based on multipath next hop. But here I have really multipath full path. So again, using the attributes, I could say, for example, for my low latency traffic, I want to use those paths. And for my high bandwidth traffic, for example, if I do backup for a subsidiary that I operate or whatsoever, I want to use different path where I know there's more bandwidth and stuff like that. And the multipath is always directly active. So as soon as I remark that the path is down, I can immediately introduce other paths if they are not already in use for this particular traffic. Then the next big attribute of the technology is, of course, security. Security was also the starting point of the whole research about a new internet technology. The idea was to create something that is not based on functionality and having security put on top of it, but rather the opposite way around. So the thought was, how can we create a secure connectivity mechanism, adding all the functionalities on top of it to make it usable for everybody? And this is really important when we talk about this technology. That's also one point of trust, actually, because there was a lot of research put into this security attribute before the concept was even made public or made usable. So that's the part where I have to admit, not all the mechanisms are 100% clear to me, because a lot of it is under the hood. It's part of the technology, and as a user of it, you probably never see it, but it gives a lot of trust that they are there and there are less things that you could hijack in the code, in the technology, because everything was based on that. Some very specific attributes that are important is the cryptographic signature of paths. That allows you to check integrity of the paths that you are using at all times, and to be very sure that there is no hijacking of paths, there is no man in the middle that is just pretending to be part of this path, and so on and so forth. So all the fun stuff that we have in the internet that is below the surface, and sometimes we don't even remark it, we can be sure here that this cryptographic signature allows us to check the integrity. Again, in the technology, you probably never see it, and you don't have to do a lot of it. A second point is related to the governance model. It's the cryptographic independence of the ISD. So all services that you use within an ISD are offered and produced in the ISD core. And that means that, you know, even if the world around us burns down, there is no kill switch somewhere on the other side of the ocean that could lead to a non-functionality of our ISD, because everything is local. The way we interconnect the ISDs is the ISDs build trust with each other and establish connectivity in this way, but they are not dependent on each other. And then there are also cyber risks, which are avoided by the technologies, mainly due to integrity checks, mainly due to isolation and stuff like this, but also with the option to exclude members by, let's say, invalidate their certificate if they have malbehavior and so on and so forth. Maybe to this point, you might have heard it from my speech. I'm not the absolute security expert in that space. There's a whole book to read about the Ssfn technology, which has a big part with security. And I recommend to spend a visit on the Ssfn architecture webpage, where there is the, let's say, the first version of the book is available as a free PDF online, and the printed edition is available as well from the old book as well as from the new book, which just came out, I think, a couple of weeks ago. It's actually brand new. So a bit more in detail how it works. You see the bubbles on the left-hand side. The ones which are colorful are representing ISDs. And then the gray ones at top of each ISD represent the ISD core. Within the ISD core, there are multiple tasks which are executed. Firstly, they establish the root of trust, so-called PRC, which is technically represented by the root CA, so the certificate authority, which then signs all the certificates that are handed out to members of the network, to ASs, different ASs. Then there is the beaconing process, which is very important for the functionality to explore the various paths within the network. What happens is that each ISD core AS sends out beacon towards downstream to its neighbor ASs, which then forward those beacons to their downstream ASs, and so on and so forth, resulting in the customer AS at the very bottom receiving all the paths that are available to reach the ISD core. That allows you to create the upstream path. In the whole process of creating a path to a destination, there's of course also a downstream path again to the target. And to reach this, you create the request to the central path server, which registers all the paths that are learned by customer ASs or ASs in general within the network. And that allows you to have all possible constellations of paths available in your database, which you can then evaluate against your policies, the path policies I mentioned before. And with that, you can create the full path and send the packet on the way. Within the packet, there are different headers that encapsulate those paths. Each of those paths or path pieces is signed. That makes sure that the integrity is correct. And you can imagine if you receive a packet, you don't have to do a lookup in any lookup table of your router. If you are in the middle, you just go in the packet header, check which is the next header that you have to use. You see there is a different AS, you know where to send it, and then you send it out. That makes the whole technology a bit lighter and less performance intense. Additional services or tasks that are executed in the ISD core are enrollment of new members, interconnection to different ISDs, as well as DNS, and maybe in future also an implementation of NTP. One point to be added here, DNS is not yet fully implemented in the products for Ssfn, so DNS needs to be part of the technology. It is described in the book, but there's no product yet that implements this solution. That's to come in the future. Then there is a second slide to this whole functionality topic. Important aspects to mention when we talk about Ssfn is that it's completely independent of the underlay. The underlay could be even a plain layer 2 link to the next Ssfn hop on the path. It could be a layer 3 network, like, for example, the internet to start with, that allows you to play around with the technology very fast. Of course, it's not the idea to have a secure, available Ssfn network on top of the internet, because you are neglecting some of the aspects right away. However, since we are talking about a new technology and we need to gain experience and also a footprint before we can make more exclusive offers, it's still possible that this is a way to implement it. Then there is any connection or communication within the network. We mentioned that a couple of times because it's really important. It offers a whole bunch of use cases that you can think of, talking about connecting different subsidiary networks, connecting different members of the financial markets that you have currently, private connections, talking about making connections that are using the internet today more secure by using an Ssfn or a Ssfn technology. So those are all use cases that are under the hood and come with the technology. It can even be extended to host level. So there is an implementation that you can install on your server to be able to even evaluate the paths directly on your server to a target system. However, in the Ssfn, we don't have that implementation in place right now. It's really more a topic of the network department as of today. And that's why it's mostly implemented with gateways that are kind of routing a whole network across Ssfn and not only individual hosts. And one aspect that I talked about before as well is the performance efficiency and energy efficiency. Due to the way the technology is introduced and due to the scaling that needs to be underlined today. You know, as we remember, when the internet started, nobody thought of this scaling factor as it has today. And that's also why the technologies are not very efficient in their way of implementation, because the concepts didn't actually assume that. That's different now with the Ssfn technology because it builds on a large scale already and assumes that it will go only in one direction in future. And what I didn't say so far is the fast failover. So within the tests, we experienced really good values of seconds or even sub-seconds until a dead path can actually be detected and one of the other paths can be taken into place. That's really good, specifically if you compare it to existing WAN technologies, where you always have to use tricks and timer tuning to reach those values. Timer tuning and tricks are very difficult when you have a distributed governance and distributed members. So that's why WAN technologies typically are a bit slower than what we see in the Ssfn network these days. But there are also downsides, and I don't want to hide them from you as we are a technical group today. The network or the technology is complex. It's new. It's something that we haven't done before in the network, and we need to gain some experience. It introduces security principles like certificate handling and stuff that we didn't have to care in the routing departments up to these days. So it is really recommended to start looking at it early and to take the time to make some experiences and verify, test it out. That's also why we start those information sessions early in the process. Christopher said it, there was one already last year, so people can get familiar with technologies and approaches that Ssfn uses to implement networking. Then there are not yet all features in place that the technology promises. That's simply because it's a bit of a chicken egg problem with the product and the development of the product and the people using it and the market players that are using it. So there's potential. That implies products are not, there are not a lot of products that actually implement the technology these days. Mainly it's the Anapaya products. Anapaya spin-off from ETH, so they are very close to the research departments. And from a carrier point of view, of course, there's again this chicken egg principles where they wouldn't invest all too much money into a technology where there are no customers for. So this is why we try to make it popular, and it's also the intention of SMB to really invest in a secure financial market, in a secure financial network going forward. Of course, a lot of it is based on opportunities, based on products that are private, based on services that are private and not controlled by the SMB. But I think it's safe to say that SMB has really an interest in making things more stable and reliable going forward, and is promoting this technology due to this reason. Then I want to exclude one of the urban myths that are around. So, you know, if you talk about security, everybody says, okay, so the traffic is encrypted. No, the traffic is not encrypted by the technology. It's a routing technology. It's basically assumed that most of the traffic that is transported is already encrypted. And of course, you can, on top of it, always create a VPN. There might be in future even products that combine the Scion gateway with VPN technologies. I don't know yet, but by default, the Scion technology does not contain any encryption of payload traffic. And then the standardization process is also still ongoing. It's not completed yet. However, there have been big progresses lately, also due to the market adoption here in Switzerland, and they are really in contact with IEEE to formulate a standard. However, it's a bit difficult to formulate a whole standard, a whole framework with everything that belongs to it, compared to standardizing a feature. And that's also why it will still take quite some time until we see a final standard for Scion technology as a whole. And then one point about IP transport on top of Scion. As I said, we use the gateways as of now, and the gateways build IP tunnels for exchanging routing information. That has some limitation when it comes to scalability. If we think about the internet, we don't know all the destinations that we really want to connect at some point in time. However, for our use case in the Ssfn, it doesn't matter at all, because we know and want to know each traffic destination that we use. And I think it's not a problem to create those IP tunnels for the moment. However, I also know that there are plans and ideas on how this could be solved within the Anapaya company. I had some interesting talks already with them. One option is, for example, to have central point within the ISD core that does the kind of public IP routing stuff and would distribute this information then down to the members of the ISD, but that's yet to come. And it's also just, let's say, a peripheral part of Scion. It's rather a question of products that are using Scion. So let's move on to the Ssfn specifically. A lot of stuff that is written down here, I already said. However, what is interesting is the whole certificate aspect. The initial certificate that is used to connect the Scion gateways the first time is valid for 30 days. And then, interesting point, the regular certificate is only valid for 3 days. Of course, that implies there is an automated way to renew those certificates, and that's part of the solution also that is offered from Anapaya. So don't worry, nobody has to change certificates every day. However, the small period of validity allows to react very fast and establish security in a way that it's not worth to try and spoof any certificates or steal any certificates and stuff like that, because they will be invalidated in a very short time. Then as 6, we are the PKI provider for the solution, together with Switch as our partner on the carrier end that is offering a PKI as well. Reactive active standby. So usually it would be 6 that is creating and renewing certificates. However, for some reason, if 6 PKI wouldn't be available due to technical error or so, Switch can take over. That's also tested in our pilot phase, and it worked really smoothly. So as a participant, you did not even remark that this service was not available for a short period and had to fail over to the backup. And as such, we have an intermediate certificate on each of the PKIs that does renewal and stuff. And of course, then there is the root certificate, which is related to the TRC, which is valid for around about 10 years with 1 year of exchange period, if you wish. Then another aspect is the admission requirements. We tried to make those as open as possible, whereas we still try to limit to professional IT departments and members of the financial market. One of the points within those requirements is, for example, that every 6 customer that has a finance IP connection as of today is automatically allowed to also offer or also order connection for Ssfn. With this, you can see that strategically we want to move away from finance IP and have all our services that we offer there today available on Ssfn and make it take over eventually. And last but not least, what is specific to the Ssfn as well is that there are only public IPs allowed in the network, more specifically unique public addressing. That means it should be IP addresses that are not used anywhere else in the internet. And the reason is that if you imagine 6 on the other hand, we have also access to internet and extranet and stuff like this, and we don't want to break any existing connection by overlapping IPs. That's not only the case for 6. I think that's the case for all participants, and only when we follow this principle, we can be assured that there is never conflict and it can be safely operated in parallel without causing problems to any of the participants. That's the reasoning behind it. Going to the next topic of access patterns, what options do you have as a customer? Generally, there are 2 models which are adopted. There is managed service and there is unmanaged service. Managed service means a carrier does everything and you basically get a connection to your existing IP network. That would include the responsibility for the gateway, ordering and operations, the responsibility for the certificate handling. The certificate is still, if the carrier does it in response or for a specific customer, of course, the certificate is still issued to the customer. However, the carrier will go through the whole process to get the certificate, install it, and also the regular renewal and everything that's related to it. The carrier may also take over responsibility for the addressing. And in case there is translation, also for the translation of those of your customer IPs to the public IP addresses that are used within the Ssfn. The uplinks can be created in any fashion that you know as today. They can be statically routed, dynamic, direct connected, whatsoever, and you can freely choose on the redundancy pattern that you use based on existing technologies. It's no different from any VPN technology that you connect as of today. And what is a bit special is that the carriers also have offers to incorporate multiple carriers. That's a bit special. Usually one carrier only works on his own lines. With Ssfn, they, for the first time, offered to operate gateways also for connections that are not in their responsibility. Then we have, in contrary, the unmanaged service, where basically everything that I just said is done by yourself, whereas the carrier, of course, supports you with enabling the uplinks and with the activation, as we know it from other connections. The carriers that are available are Swisscom, Sunrise, and Switch as of today. Primarily footprint is Switzerland, whereas Swisscom also promoted that they have the option to connect customers around the world. Of course, not everywhere around the world, but this needs to be negotiated with the carrier itself once the requirement comes up. One thing to add here, the carrier landscape is not static. So there are other carriers that want to join this market as well. I think as soon as this information is public in future, or if there's an update on the carrier situation, that will be reflected on our webpage as well, which is referenced at the very back of this presentation, but also very easy to recognize or remember is sixgroup.com/Ssfn. Let's go one step down to the deployment topologies that we verified or that we know from the pilot environment. This is now for unmanaged services, of course, where you do your connectivity on your own and you have to take care on the topology and on how you connect. We have this model of site redundant connection with an interconnected access platform. You see here at the very bottom, these two data center sites are interconnected, and this represents a routing platform with dynamic routing across the sites, and as such also a dynamic failover across the sites. In this setup, it allows you to advertise your SIAM networks or your Ssfn dedicated networks on both sides with the same metrics, with the same priority, and run complete active-active scenario. Assuming, again, that your access platform does the transformation or makes sure that symmetry across firewalls and stuff is given. You can have one or multiple carrier uplinks per gateway. It's also tested and verified. And in our pattern that we know, there was always BGP used as the dynamic routing protocol between the SION IP gateways and the rest of the network. There are filters available and recommended to be used on different levels. Of course, you would filter your BGP connection to make sure that you only advertise what you really want to advertise to the Ssfn network, as well as on the other side that you only learn known networks from those gateways. And there's also the option to implement filters on the gateways themselves. So what you learn from a specific neighbor, or let's say member, because it doesn't need to be a neighbor actually. And again, as well, on what you advertise on the other side. So it's pretty much like BGP filtering as we know it. The second pattern that I want to mention is the static cluster setup, where you don't need a routing protocol between the gateways and your network. In this case, it would be based on a virtual address that is on either one of the cluster members, and you just have a static configuration that points to this virtual IP as an X-top. And if one of the gateways goes down, the other one takes over. And the sites, as you see down here, are independent. That means this is not necessarily a router. This could be any devices, possible to be direct firewall that connects the gateways via switching platform, for example. And it implies that you use an active standby setup for certain IP prefix. Means that you would advertise one prefix from data center A primarily, and maybe as a backup from data center B. Maybe not. Maybe you would use a completely different IP range on data center B and advertise this one to the network and handle the redundancy on a different layer, applications that do failover or whatsoever. That depends on how your service is created and how you want to access other services. For other services, it's not a problem. Typically, if via data center A, your connection would be broken, you would just go via data center B and use a different source address. That works without problems, but requires a TCP session to be re-established. Other than that, for the filters on the gateway, the same applies. So you can still filter on what networks you really want to learn on your gateway, and you can still filter on what networks you want to advertise to different customers or connections that you operate. So now we talked about how an implementation could look like. Now let's quickly have a look on what needs to be done or what the implementation process could look like. What needs to be done first? I think the step 0 is what we do today. Gain knowledge, gain experience, look around the market and have some impressions about the technologies and the options that you have. When you decide to go in this direction, a first point would be to analyze what you want to do with the connection, what services you could use from the Ssfn network, what you maybe could also offer as a service on the Ssfn network, and what other use cases that you can think of that could be addressed with the Ssfn network. Based on that, you would define the topologies and the configuration that you want to use, and the services, what needs to be changed on the service level. Second point, and maybe the point where it gets really down to the ground, is you need to, of course, order connectivity from the carrier, as well as you need a product support. At this point, you would do the decision of managed service or unmanaged service, and that would depend on, do you only contact your carriers, or do you also contact Anapaya as the product provider directly? And this is also the point, if you choose to go with Anapaya, they can offer you services and consulting again on your implementation. So that leads back to step 1, where you define what you really need. only once you have done these orders and the hardware is just in front of your door, it makes sense to apply for a certificate of Ssfn for the initial certificate, because as you said before, as I saw before, well, combination, as we saw before, the certificate for initial setup is valid for 30 days. So when you order it, you should really have a plan for the implementation, or that you have, otherwise you have to go through the process twice of ordering a certificate, which is not required. After that, once everything is installed, you activate the Ssfn certificate on your gateways and go through technical testing of your interconnection. During this process, we can always assist you from SIG side with some consulting if you have any questions or whatsoever. Anapaya can assist, and the carriers are also willing to support you during this process of onboarding to the Ssfn network. Once the infrastructure is ready, it's about migrating services that you have, and that's then a recurring process of connecting a test instance, making sure it works, having some operational time until you switch production. So that's the usual process of service migration. And I think that's pretty individual for every participant. Important to say here, Finance IP is still around. So you can put backup routes in place that make you use the Finance IP network in case you don't feel comfortable for a full switch over at this point in time. Finance IP will go away once we have migrated all customers. So I think at the moment there is no final end date for the network. However, there is an end date, or there are end date for individual services. Not all yet fully defined, but they will be defined shortly, specifically for SIG and EuroSIG, where we have a definitely a strict goal and also a validation that the technology works and that the providers are willing to move in this direction. That will be communicated shortly. Last but not least, what are the lessons learned? What do you need to be prepared for when you look into Ssfn technology? First of all, the implementation. Not all features are yet implemented. Not everything that you imagine could be possible with the technology is yet possible. Same with best practices. You know, as the technology is new, a lot of stuff must be evaluated and specifically tested before you actually use it. So I really encourage everybody that establishes a Ssfn connection to verify that it works, to do BCP tests before you actually put production onto those links, to make sure that the way you implemented it for your specific environment really works. PKI is a topic that was challenging for us as well. We haven't done a customer-facing PKI for a while. We have it in the stock exchange, but we don't have it in the other areas of the network. And for once, it was really with the project, and it was a bit challenging to bring it to life. The initial position was it would be great to have a professional PKI provider hopped onto the network and the project, but this actually didn't happen. So we had to build it ourselves. But in the end, I think it was a good learning. It helped us to further understand and own the processes around Ssfn. So it was a good learning, but it was tough back then. And the technology has still some black spots. If you want to use a feature that maybe nobody has used before, or not in the way that you want to use it, take care. Do good testing and make sure that the implementation really fits what you expect. About everything around the technology, it's new. Sources of knowledge are limited, the community is limited, and you always have the risk of market adoption. Means that if the market does not adopt the technology well, the knowledge will remain limited and the community will remain small and the technology might eventually go down. We don't hope that this is going to happen, but that's of course a learning that we have to do, that it's important not only to know yourself on how the technology works, but also to spread the knowledge that you have, spread the experience that you gained, and get in contact with a community that can support you in case you have a question that is not written in the book. And of course, we also faced some conceptual errors during the early adoption stage where we wanted to do stuff which was not quite supported or maybe didn't quite make sense using Scion. So we had to do quite a learning curve ourselves as well. And about the product, because you know, the product the implementation is key for us as end customers. It's pretty much the same story as for the technology. It's new. Not everything works. You have to do proper testing. Management integration is done by a slightly different angle. It's not a fully productized Cisco platform that offers the same interfaces as the last 20 years. It's new, it's going different ways with telemetry export, for example, which is very beneficial, but you need to get used to it and you need to put some effort into the technology as well as the product to understand it. The gateway is built on a Linux operating system, and the system is, for now, still visible. So you can interact with the Linux world and you have to interact. That means you have all the pros and cons on the gateway available. Pros, functionality. Basically, if something is missing, you could add it. For example, different authentication backends or whatsoever. On the other hand, you also have to make sure that everything that you do is hardened as you expect it, and it's not hidden under a shelf that nobody has access, but it's rather you need to make sure that the access is protected as well as the system itself. We had some changes as well in the product, of course, and we had some, let's say, a finding phase as well with Anapaya that we were undergoing. So processes and structures within the companies are changing and of course must be changing. It's a startup. We cannot expect to have a huge organization in the back. This has the pro that they are very flexible. It's very good people. A lot of them come from the research area where Scion was already developed, and they can help you very flexibly. On the other hand, of course, operational aspects are more difficult to fulfill if you have a smaller organization, and operational skills for a company come with experience. So I think we did quite some way already, and the company and the operations model and everything is quite good by now. However, there is always room for improvement with the company growing. So that's pretty much it from my end. And with that, I would hand over to Christopher again for wrap up and Q&A session.
Thank you very much, Beat, and also thank you, Thomas, for your nice explanations. Before opening up for questions, and I just posted in the chat, please feel free to start asking questions, especially in the chat, or think of questions. Some also 2 or 3 points I'd like to focus on from the project view, what we learned there. I think the main point has been mentioned 2 or 3 times by both Thomas and by Beat, and I'd like to put it on the big scene. Dream big, start small. What I want to say with that, there are lots of things that you can do with Ssfn. We've seen use cases, not just connecting to SIX, but also connecting amongst banks, connections to subsidiaries, and so forth and so on. A lot of opportunities. However, because it is a new technology, do start small, start with one use case, start early, because it does take time to build it up, but dream big. And that's also part of the next points which I put on here, is also then manage your expectations. I tell management what is going to happen, give them the big picture, but also tell them we're going to start off small, and then we're going to gradually go on up, and then it'll come out very well. So do please take extra time into consideration. Do start early, build up your knowledge base on it, build up your whole experience on it, and that way you gain confidence to actually really trust it and really use it going forward. Some final comments in the sense of a wrap up. What does it take to set up an Ssfn connection? Beat went through the various steps with you. We expect it to take at least 3 to 6 months. It can take longer due to lead times, ordering certain items. So again, another reason to start a bit earlier. It's mostly the network specialists are the people involved in setting it up. So you're not talking as usually maybe in 6 products. So it's not the product itself, but it's actually more on the network level here that we're talking about. And one question that also always comes up, well, what is this whole thing going to cost? Excuse me. We reckon that on average it will be a medium 5-digit figure per year. So it's not the biggest project you have here, but it does just add on here a bit. The various use cases, I think we've mentioned a number of times. We will also mentioned about the decommissioning date for Finance IPNet, which, as we said, also will be on a service per service level. And Thomas also mentioned that Swiss National Bank has informed that it plans to introduce endpoint security, requiring, for example, in this context, every SIG participant to have an Ssfn connection for the data exchange with their service provider. Also, we have mentioned that we've now got a governance level or a governance structure on top of Ssfn, allowing also participants to participate in the development of Ssfn. And as we also heard, that it can be leveraged for further use cases. As we said, the ISD Ssfn is encapsulated. It is separated from everything else. The Cyan technology technology, however, which can also be implemented in other ISDs, of course, provides further use cases which we haven't gone in today, but which can include things like remote workforce, which have been tried and tested. It can be used, for example, to reach specific websites. And just going forward, this could be quite interesting for banks offering e-banking services or the likes. And of course, as also mentioned many times, all the service providers, SIX included, are very happy to support you in setting up your the Ssfn connection to support you in design setups and the like more. We would like to take this opportunity, Thomas, Bear, and I would like to take this opportunity to say thank you very much for joining us today, listening in. It's been a pleasure for us to be able to talk to you and to tell you about Ssfn and how it works, technical details. We hope you've gained some insight into here. And as said, we recommend starting now, looking into what it takes to get a Ssfn connection, building up your knowledge so that you are ready rather earlier than later, so that you've got enough time to be able to set everything up. Have a great weekend. Bye.
Thank you. Bye-bye.
Bye. Hope see you soon in the Ssfn universe. Bye.
Thank you, guys. Have a good day.